This lecture video is called Linear Functions, and so we're going to do a couple things here. We're going to look at writing lines using function notation, and we're also going to look at parallel and perpendicular lines. So our first examples are just going to be writing the equation using function notation. Remember, function notation is f of x equals mx plus b, or that's the same as y equals mx plus b. But since we want function notation, we need to make sure that we replace that y with f of x. So the first thing that we need to do is make sure that the equation is solved for y. And this first example is, the only thing that we have to do here is replace the y with our function notation f of x. So that would be f of x equals negative 4x. In this next example, x minus y equals 4, this one is not solved for y, so we need to get y by itself. And so I'm going to add the y to both sides because I want a positive y, and right now the y is negative. That gives me x equals y plus 4. And to get this y by itself, then we need to subtract 4 from both sides. And that gives us y equals x minus 4. And then just replace this y with f of x. So f of x equals x minus 4. In the next one here, we have 4x plus 3y equals 12. So we want to get this y alone. So we're going to subtract 4x from both sides. That gives us 3y equals negative 4x plus 12. And then we need to divide everything by 3 to get this y completely alone. So just make sure that you remember to divide everything in the equation by 3. That gives us y equals negative 4/3 x, and then plus 12 divided by 3 is 4. And then just replace the y with f of x. So we're going to have f of x equals negative 4/3 x plus 4. The next thing that we're going to look at is parallel lines, and parallel lines have the same slope. So the slope of one line equals the slope of the other line. Perpendicular lines, however, have slopes that are negative reciprocals of one another, and so if you have one slope, m1, then that's going to be equal to negative, so we change the sign, and then it's going to be 1 over m2. So you flip the slopes upside down and change their signs. So we're going to write the equation of each line and write the equation using function notation. And this line passes through the point 1, 4, and it's parallel to the line 2x minus 3y equals 1. So the first step is to figure out what the slope of this line is, and then our line is going to have the same slope because we want them to be parallel. So in order for us to figure out what this slope is, we need to solve this equation for y. And then the slope will be the number in front of x. So the first thing to do to get this y by itself is to subtract 2x from both sides. So I'm just going to write this equation down again. 2x minus 3y equals 1. So I'm going to subtract the 2x from both sides. That gives me negative 3y equals negative 2x plus 1. And then we need y by itself, so we have to divide everything by negative 3. That gives us the equation y equals, now we have negative 2 divided by negative 3, so that's a positive 2/3 x, and then positive 1 divided by negative 3 is minus 1/3. So what we're interested in from this equation is the slope. So m equals 2/3, and we want the same slope because we have parallel lines. So our slope is going to be 2/3, and it passes through the point 1, 4. So there is a form of a line called the point slope form. And this has a slope of m, and it passes through the point x1, y1. So the equation is y minus y1 equals m times the quantity x minus x1. So this y and this x are the x and y in our slope-intercept form that we're going to need later on. This y1 and this x1 are the numbers or the points that it passes through. So that's going to be this 0.14 here. So we're going to have y minus y1, and y1 is 4, equals our slope, which is m, 2/3, times the quantity x minus x1, oops, and x1 is this point right here, 1. And so now we just want to solve this for y and then replace the y with f of x. So the first thing that we need to do to solve this for y is to distribute this 2/3. So we'll have y minus 4 is equal to 2/3 x minus 2/3. And then we need to add 4 to get this y alone. So we'll have y is equal to 2/3 x, and then 4 is the same as 12/3, and negative 2/3 plus 12/3 is plus 10/3. And then just replace the y with f of x. So f of x equals 2/3 x plus 10/3. In our next example, we want the line that passes through the point negative 6, 4 and is perpendicular to the line 2x plus 5y equals 10. So first we need to solve this for y, determine what the slope of this line is, and then the slope of our line is going to be the negative reciprocal. So to solve this equation for y, we need to subtract the 2x. That gives me 5y equals negative 2x plus 10, and then we need to divide everything by 5. So we get y is equal to negative 2/5 x plus 2. And so here's the slope of this line. We need to change its sign. So that's going to be positive, and then flip it upside down. So positive 5/2. So you have to do two things. Change the sign, making it positive, and flip it upside down. So that would be 5/2. And then we're going to use the point slope form again. And the point slope form was y minus y1 equals m times the quantity x minus x1. So that will be y minus the y-coordinate of the point that we pass through is 4 equals our slope, and our slope is right here. It's 5/2. Oops. And then times the quantity x minus x1, and x1 is this negative 6. So we have y minus 4, and we're going to distribute the 5/2, and also remember minus a negative is adding. So it's going to be 5/2 x plus, because minus a negative is positive. And just over here on the side, we're going to do this 5/2 times 6/1. And 2 goes into itself once, and into the 6 3 times. So we have 5 times 3, which is 15. And then we're going to add 4 to both sides. And that gives us y is equal to 5/2 x plus 19. And then just replace the y with f of x. So f of x equals 5/2 x plus 19. In our next example, we're given that the slope is -1/2 and passes through the point 10, 5. And so we already looked at the point slope form, and just to show you one other way that you could do it, we know that y equals mx plus b. This is the point, or the slope-intercept formula or form of the line, and so we can use this if we would like. And so I'll go through this example doing it both ways, using this to figure out what b is and also using the point slope form. And it doesn't matter to me which method you use. So this is slope-intercept, and this is point slope. So you can use either one of those two ways. So we have all the information we need to plug into either one of these. So let's do the slope-intercept way first. I'll do that way in red, and then I'll do the point slope form in blue. So if you do it this way, then you replace the x and y with the x and the y from the coordinate that the line passes through. So the y coordinate is 5, so we're going to replace the y with 5, and it's equal to m, and our slope is -1/2, and then times the x value that that the line passes through, which is 10, and then plus b. And so we just need to figure out what b is. I have 5 equals -1/2 times 10 is -5 plus b, and then to get b we just have to add 5 to both sides. And so that gives us b is equal to 10. And then we need to write this in function form. So that would be f of x equals my slope, which is -1/2 x, and then plus b, which is plus 10. Now to do it using the point slope formula, it's very similar. So we're going to have y, and then minus the y coordinate that the line passes through, which is 5, equals our slope, which is -1/2, times the quantity x minus the x coordinate that the line passes through, which is 10. And then we just need to solve this for y. So we're going to distribute this -1/2. That gives us y minus 5 equals -1/2 x. And then -1/2 times -10 is plus 5. And then we're going to add 5 to both sides. And that gives us y is equal to -1/2 x plus 10. And then write it in function notation, which we have right here in the red box. Now in the next few examples, we're just given 2 points that the line passes through. So before we can write out the equation of the line, we need to figure out the slope first. The equation for the slope, remember, was y2 minus y1 over x2 minus x1. So the important thing to remember here is that whichever point you decide to start with, you start with that for both the x's and the y's. So we'll do it both ways, just so that you can see that we get the same number no matter which way we do it. And so we're going to do the difference of the y's first. So that's going to be 9 minus 3. And then the difference of the x's on the bottom. So that's going to be 3 minus 6. And 9 minus 3 is 6. And 3 minus 6 is -3. And so that gives me a slope of -2. So had I chosen to do the subtraction the other way, which I'll do in red now, we still would have gotten the same result. So we could have done 3 minus 9 on the top. But if I do 3 minus 9 on the top, then I have to remember to do 6 minus 3 on the bottom. And 3 minus 9 is -6, and 6 minus 3 is 3. And so we still get a slope of -2. So again, you just have to pick one of the points and start with that one for both the y's on the top and the x's on the bottom. So now let's finish this out. So now we have our slope, and we also have not only 1 point, but 2 points that this line passes through. And so if one of the points is easier to use, then use that. Particularly if one of them happens to be the y-intercept. So if the x value is 0, and then that's the y-intercept, and that would be the easiest point to use because it gives you b right away. But that's not the case here, so you can do it one of the two ways that we did example C. I'm going to use the point-slope formula. If you're more comfortable using the slope-intercept formula, by all means you can go ahead and do that. But just so you get used to using this other form of the line, that's what we're going to do here. So we're going to have y minus the y-coordinate, and I'm always going to use the first point unless for some reason the second point is a whole lot easier to use. So I'm going to use the point 6,3, but you could use 3,9 if you wanted. So the y-coordinate here is 3, so that's going to be y minus 3 equals our slope, which is negative 2, times the quantity x minus the x-coordinate, and the x-coordinate of the point I'm using is 6. So now we just need to solve this for y. We have to distribute the negative 2, giving us y minus 3 equals negative 2x plus 12. And then we need to add 3 to both sides. That gives us y equals negative 2x plus 15. And the last step is to replace the y with f of x. So f of x equals negative 2x plus 15. In our next example, the line passes through negative 3, 4, and 7, negative 6. So I'm going to calculate my slope. And I'm only going to do the slope in one way this time. So I'm going to take negative 6 minus 4. And on the bottom, it's going to be 7 minus a negative 3. And negative 6 minus 4 is negative 10. And 7 minus a negative 3 is plus 3, so that would be positive 10. And negative 10 divided by 10 is negative 1. So I have a slope of negative 1. We're going to use the point-slope formula. Y minus y1 equals m times the quantity x minus x1. That'll be y minus the y-coordinate, and so that's 4, equals our slope, which is negative 1, times the quantity x minus the x-coordinate, which is negative 3. So first of all, this minus a negative 3 becomes plus 3. That gives us y minus 4 equals negative x. And then, so I'm distributing the negative 1, so that's negative x. And then this is plus 3, so that will be minus 3. And the last step is to add 4 to both sides. That gives us y equals negative x plus 1. And then replace the y with f of x. And you can always check to make sure that your equation is right by plugging in both of the points and making sure that they give you true statements. So if I plug negative 3 into x, do I get 4 for y? Well, negative 3 is positive 3 plus 1 gives you 4, so that works. If I plug 7 in for x, do I get negative 6 for y? And plugging 7 in here will give us negative 7. Negative 7 plus 1 is negative 6, and so we do in fact get a true statement for both of our points. The last two examples are examples of some special lines. So the first one is a horizontal line, and remember, a horizontal line has a slope that's 0, and the form is y equals c. It's a constant, and so y is always the same. No matter what x is. So you could go through all the work that we've been doing for all of these, but y is always going to be the same number no matter what x is, and the equation has the form y equals that number, and it passes through the point 5, negative 2, and so the equation must be y equals negative 2. And we want function notation, so that would be f of x equals negative 2. The last one, we have a slope of 0, and it passes through the point 2, 1. So again, a slope of 0 means that it's horizontal. and it has the form y equals c, and so this time y is equal to 1, the y coordinate of the point that it passes through, and so function notation for that would be f of x equals 1. And that is the end of our lecture on writing an equation, or writing lines in function notation. Let me know if you have any questions. Thanks.